Okay, my dear children, now in the earlier chapter we discussed how to connect or how to interconnect several cells. Now in this chapter we'll be observing how to interconnect several bulbs together. So however, you know that the two types of connections that can be observed is parallel or series. So those are the two types of connections that we can observe. So here it is given the systems of bulbs. So like in the earlier case, here two figures are given to you. Observe the two figures very carefully. So you know that if you take a torch bulb like this, right, there is a metallic cover at the base and at the bottom there is like a tip. So the two terminals are the tip at the bottom and the metallic cover around the bulb. Those are the two terminals. Okay. So my dear children, here two systems are given. You can observe it very clearly. There are two systems. There are two different systems. In the system 1, see, metallic plate is here. Top point is connected with the metallic plate of the second one. Once again, the top base is connected with the metallic plate of the third one. Then finally, metallic plate is coming out from the third one, right? Okay, there is a problem in here right now. Okay, now, right? There is a small bit of a problem in the figure. Actually, now when two terminals, when they are connected to each other, right? In these cases, all three bulbs should have to be lighted up now. So there is a small bit of a problem here, right? What's that problem? When you are connecting cells together, my dear children, it should be like this. So this is the first cell, the positive terminal. This is the third cell, the negative terminal. So first cell's positive terminal should come with the third cell's negative terminal, not the positive. If you connect it opposite side, what will happen? If you connect it in opposite direction, what will happen then? Like this. The same thing has happened in this figure as well. Like this, what will happen? See? Now, the thing is that charges coming from here will travel to there, and from there to here, it will not travel. Why? Because both the terminals are negatives. There is no potential difference in it. So it will not travel. So therefore, this is wrong. So if one terminal is positive at here, at the second one, the other should be negative. Otherwise, there is no use. Observe this system carefully. This one comes out to here. The bottom part once again runs to here. Then this one should not come from the same area, but it should come from the bottom like this. So in your textbook, there's a small bit of a change, right? We should have to do this change. It's wrong. Otherwise, this third bulb or the entire bulb system will not work, right? So we have to recorrect it. So this is the correction. It should not come from here. It should come from here. Right then. In the third case, my dear children, so let's explain about the first diagram here. So in the first diagram, now you can see very clearly, there are 3 bulbs, not cells, right? So there are 3 bulbs in here. In the first case, one comes from the metallic cover and the other terminal from the below runs to the other metallic cover. Other terminal from the below runs to the metallic cover, then the below terminal comes out. So this is the tip at the below, tip. This is the cover. This is the first cell. This is the third cell, not the cell. This is the first bulb and that is the third bulb. So this one terminal is coming from the cover of the first bulb and from the tip of the third bulb, the second terminal comes. So opposite terminals interconnected each other. If opposite terminals are interconnected each other, then it is a series connection. So when bulbs are connected as in figure A, it is called a series connection like this. Opposite terminals always together during the connection, right? And after the connection, one terminal coming from one electric appliance, right, should be a positive one or else a different terminal, and from the final electrical appliance or instrument there should be another terminal and that should be opposite in relation to the first one, right? So if positive is coming from here, negative should be there. Okay, if metallic plate is coming from here, then the tip should be there. Like that way, opposite terminal should be there in a series connection. This is, let's see what happens in the second figure. So this is, see, this one is like this. So this is the tip, this is the tip, this is the tip, then all are interconnected each other, tips. This is the metallic cover, this is the metallic cover, this is once again the metallic cover. All metallic covers are connected together, covers. So all covers are together with all tips at the other side. So same terminals are interconnected each other. And finally they are being connected to the circuit or to the electric source. So this is C. When the connection as in the figure B, it is a parallel connection. So figure B is a parallel connection. So these are the 2 types of bulbs that we can observe, right? It's same as the connection of cells. It is same as the connection of cells. Same thing is going to apply. There's no difference at all, right? But the thing is that the electrical appliance is getting changed in these occasions. Electric appliance is getting changed. In the earlier case, we used the cells. Now we are using bulbs, right? In the earlier case, it was quite easy to identify because there are positive and negative terminals. However, in this case, there are no such positives and negatives, but there are also 2 different terminals. Okay, so you have to identify whether same terminals are connected or different terminals are connected each other or not. Okay, so this is how to get some idea about series connection of bulbs and the parallel connection of bulbs, my dear children. Right, then you are given series bulb systems. So here we are discussing about the series connection of bulbs, right? Series connection of bulbs. We are discussing about the series connection of bulbs here. So mainly what we are going to do here is we are going to connect several bulbs in a series connection and we are going to identify what's going to happen. What will happen to the brightness on those bulbs? Okay, right. So let's see what are the materials that we need in conducting this activity. So first of all, you'll be needing bulbs. Torch bulbs are more convenient. right? Then dry cells, switches, right? Switches. After that, wires, connecting wires. So we'll be needing these things, torch bulbs for sure, torch bulbs. Then after that, dry cells, then some switches and some connecting wires in connecting purposes, right? So you know that upon connecting, right, rather than like wrapping them around, you can use crocodile clips or some other clips that can hold connecting wires together, right? So you can use those things as well if you need. Okay then. So the method of connecting these instruments together is given in here. Now, once again, you are given with 3 figures, right? Once again, you are given with 3 figures. Figure 1, this one, just a one simple cell and one single bulb. In the second one, 2 bulbs interconnected each other, right, in the second figure. The 2 bulbs are series connected to each other. How can you say it like that? See, cover, then the tip comes to the cover, then the tip comes. See, so that is correct. It should be a series connection. In here, it's coming from the cover. In here, it's coming from the tip. So it is correct, series. So once again, you have to connect 2 bulbs in a series connection, but to a single dry cell. In the third figure, to 2 dry cells, you have to connect the 2 bulbs, which is connected already in the series connection. Right, my dear children? So this is the way of making these 3 circuits. Then after that, what you have to do? First turn on this one, observe the brightness. Then turn on this one, observe the brightness. Then turn on third one, observe the brightness. Then turn all 3 at once and observe the brightness. Okay? And we have to compare the brightness of the bulbs and come into a conclusion according to our observations of the brightnesses. Right, now let's see how to conduct then. Connect one bulb with a switch and a cell as shown in the figure 1. Connect 2 bulbs with a switch and a cell as shown in the figure 2. Connect 2 bulbs joined in series to a switch and 2 cells as per to figure 3. Now according to figure 1, 1 with 1. Figure 2, 1 with 2 bulbs series. Figure 3, 2 with 2 bulbs in series. Switch on all 3 circuits at the same time and observe the brightness of the bulbs, right? So after that, we have to turn on all 3 at once and observe the brightness. So if it is okay to not to light up them separately, because by that way we can't get a certain idea, no, right? Actually, you can if the brightness is very less, but however, it's probable to light them at the same time. By that way, we can finish up with the activity quite fast, right? So it's okay to light up all 3 at the same instance. Right, my dear children. Now, this is the way of conducting the activity. Okay, let's head on to the lab and we'll conduct the activity and let's see like what kind of a thing is going to happen with the brightness of the bulbs when they are series connected to each other. Okay, my dear children, now let's observe what is going to happen during a series connection of bulbs. Now, in this activity, already I have prepared the 3 systems. This is system A, or the first system, first figure which is given, right? So we divided we categorized the 3 instances as figures. So this is the circuit which refers to the figure 1. This is the circuit that reflects in figure 2, and this is the circuit that reflects in figure 3. Okay, so here now you can observe this is the switch. The 2 terminals, one terminal runs to the bulb, and from the bulb it comes to the dry cell over here. So when I'm going to turn on the switch like this, the bulb is going to glow, right? Okay, so this is the first setup which I have prepared by using just one single dry cell. In the second instance, there is one dry cell once again. So you know that in a dry cell there is about 1.5 volts. Okay, so when you interconnect 2 of these bulbs, torch bulbs especially, torch bulbs are usually having about 2.8 volts. 2.8 volts, that's a usual amount. However, if you interconnect these two in a series connection, the amount of voltage that is going to draw out from one of these bulbs is going to be very high. Okay, means that all the voltage is getting absorbed for the enlightenment of the first bulb, for the illumination of the first bulb, and there won't be any voltage to travel to the second bulb. Okay, so actually what happens in a series connection is that the voltage is going to divide. I'm going to explain further things related to this division process after that. But however, you could observe in this case, when I'm going to turn on the switch, as I have used only one dry cell, the second bulb will not light up. It's because that all the voltage is been provided to the first bulb, right? So see, just showing a simple brightness, just a small bit of a light can be observed in the filament, that's it. The second one is not glowing at all. It's because the voltage given out by the dry cell is completely getting absorbed by the first one over here, by the first bulb over here, and there is no voltage to travel for the second bulb. Therefore the second bulb will not light up. So during a series connection, voltage is getting divided actually. That's why it happens. So in the third case now, I have used 2 different dry cells. Now in this case, right, in this case 2 different dry cells means about 3 volts. So there is a remainder after 2.8, there is a remainder, means that both the bulbs in this case should light up. So when I'm going to turn on, see, both the bulbs are going to light up. But however, when you compare the brightness of these 2 bulbs with the first instance in here, there is a considerable change. I mean, like this first one is showing some amount of a high brightness, while the third instance in here, some amount of a less brightness is shown, even though when I'm going to use 2 dry cells, right? Somewhat low, not that much low, but however, the brightness of this one is somewhat higher than these 2. It's because now the voltage given is not divided in this system, as there is only one. So the voltage given across these 2 is getting divided into 2 different parts. So these 2, when it is getting divided, it's like, right, you know that these things are providing about 3 volts. But however, when passing through the circuit and when we consider the other factors like resistance, some amount is getting lost. So therefore, right, the brightness of these 2 is somewhat lesser, somewhat, not that much lesser, but somewhat lesser than the first one. So now let's turn on the third one so that you can observe a good reading. Actually now here the second one is actually not working at all. But the first one is showing just a simple amount of a brightness, right? The filament of the bulb is has some amount of a brightness, that's it, right? These two are showing somewhat good brightness. However, the brightest one is this thing. You can observe it very clearly when you are looking at the bulbs. So my dear children, the observation is when you are using one single bulb, right, with one single dry cell, it carries a somewhat greater brightness. In the second one, very less bright, right, very less bright. Let's assume that this is also going to light up. If so, very less amount of brightness is observed in the second one. In the third figure, brightness is greater than the second instance in these two, but less than the first one, right? So during a series connection, what happens here is that the current or the voltage across each of these items is going to divide and travel. Okay, if there are two units, then the whole voltage is getting divided into two equal parts. However, those things should be identical. So we'll be clarifying these things furthermore when we are discussing about the lesson. So the observations and the conclusions of this activity are really simple, right? So let's head on to the classroom once again and we'll write down our observations and our conclusions from the series connection of bulbs. Okay, my dear children, we conducted the activity and you could observe that in the first instance, brightness of the bulb is more. In the second instance, brightness is very less. Brightness is very less. In the third instance, brightness is somewhat greater than the second one but less than the first. Okay, somewhat greater than the second instance, because you know that when you are providing two dry cells together, right, somewhat more current is going to be given out from the circuit as the voltage is going to increase. So by that, what is the conclusion that we can take from this activity? Conclusion is that upon connecting these bulbs together in a series connection, their brightness is going to reduce. So if you want to get the same brightness, you have to provide more dry cells to the circuit. Okay, as these are bulbs, so especially we are discussing about bulb systems now. So the conclusion is given according to the bulb system. That's why I use the bulbs. Okay, so when connecting these bulbs in a series connection, the brightness is going to reduce, and if you want to increase the brightness, you have to provide more dry cells to the circuit. So we can write down our observation and conclusion like this. Observation. So figure 1, 2 and 3, let's separate. Right. Figure 1, it's like this, the simple circuit that we connected by using simple dry cell and a switch. Right. So this is the first one. So in figure 1, more brightness. More brightness. Then figure 2, the circuit in figure 2. In the circuit in figure 2, only one cell but two bulbs connected series to each other like this. Okay. So here in figure 2, very less brightness. Very less brightness. Then figure 3, third figure, in figure 3, it's like this, two bulbs together with two tri-cells which are interconnected like this, in a switch like this. The figure 3, third figure. So in third figure, brightness is more than 3, less than 1. Here the brightness is more than 3 but somewhat lesser than 1. Okay, right. So at the conclusion we can write, in a series connection, of bulbs, according to the number of bulbs, according to the number of bulbs brightness change. So in a series connection of bulbs, according to the number of bulbs, brightness change, right? So we can write within brackets, more bulbs. If there are more bulbs in the system, less bright. Then if there are less bulbs, then more bright. So this is our final conclusion from the activity. So if you want to increase the brightness, you have to provide more cells. Okay, right? So we'll write down that one also. So here, actually here I have written that brightness is more than 3, but the third figure is this one, no? So the brightness should be more than 2, not 3. This is the third figure, the final one, the third circuit, the final one. So here we used 2 dry cells. So therefore there are more potential energy and more current is given. Therefore it should light up even more than the second instance, right? So brightness is more than, it should be more than 2 but less than 1. Okay, so I have recorrected it. Okay, so then the next one is by increasing, right? By increasing the number of cells, by increasing the number of cells, by increasing the number of cells, brightness of the bulbs can be increased. Right. So once again, let's see what are our observations. So our observations was quite simple. In the first figure, right? In the first figure or in this first circuit, when you are going to turn on, more brightness is given out from the bulb. Then in the second figure, when you connected two bulbs together in a series connection with just one dry cell, very less amount of brightness is given. Very less amount of brightness is given. Then after that, when you connect, like in the third figure, two bulbs in a series connection with two dry cells, somewhat more brightness can be observed rather than the second instance. However, it is less than the first, right? So brightness is more than the 2 but less than 1. Okay. So from this activity we took a conclusion that in a series connection, right, in a series connection of bulbs, according to the number of bulbs, brightness change. So according to the number of bulbs, the brightness is going to change. Then the next one, the explanation is given somewhat more bulbs, less brightness. If there are more bulbs, the brightness is less. Less bulbs, more bright. Right? So if there are less number of bulbs, more brightness can be observed. Then by increasing the number of cells, brightness of the bulbs can be increased. By increasing the number of cells, we can increase the brightness of the bulbs. Right then, now let's head on with the other one. So according to the activity, is clear that brightness of the bulbs decreases with the increase of bulbs connected in series across a voltage supply, right? So we discussed this thing. So I have explained even more when I was writing down the conclusion. But the initial brightness can be obtained by increasing the number of cells. Thus, several low voltage bulbs can be lighted from a high voltage supply when they are connected in series. So my dear children, I think you have observed in Vesak pandals and in Vesak ceremonies, we use several light, streams of lights, right, to decorate our houses. Bunches of lights can be observed. Size of them are very small, like in this kind of a, right, size, very smaller. But however, if there are like hundreds of bulbs, right, if there are like hundreds of bulbs, decorative bulbs, if you connect that into a main power supply, I mean like in your household, you know that there are plug panes, no? So you insert that into a plug pane. The whole stream of lights are going to light up. It's not going to burn. But however, don't do this thing at home, okay? However, if you just take one bulb and you are going to plug it into a plug pane, definitely the bulb will explode. It will explode actually, right? It will not burn out, it will explode. What is the thing, or what's the scientific explanation for that thing? It's because that when you take that stream, right, when you take the stream of light bulbs, all of the light bulbs are series connected to each other. So in here we discussed that during a series connection, my dear children, brightness is getting reduced because the voltage is getting divided. Voltage is getting divided and it is being supplied to each of the electrical appliance when they are in a series connection. voltage is getting divided. Like, let's take, there are several bulbs like this. All of these bulbs are same in all aspects. The maximum voltage that they can hold, maximum voltage, like there are 1, 2, 3, 4, 5, 6, 7, 8, we'll draw another 2 to become 10, 9 and 10, right? So this is my circuit now. There are 10 bulbs, 1, 2, 3, 4, 5, 6, 7, 8 and 9 and 10, right? So there are 10 bulbs. I'm going to assume that the maximum potential voltage that this one bulb can bear is just 25 volts. That's it. 25 volts. Okay. This bulb can bear up to a maximum of 25 volts. That's it. Now I'm going to take this one bulb and I'm going to plug it into 230 volt, right? Electrical system at your house, 230 volts. What will happen? Definitely this one will burn up and it might also explode. Why? Because 230 of a voltage is given. However, this can bear up to 25 volts. What will happen then? This is so much greater than the maximum amount which the bulb can bear. Definitely the bulb will burn out. But what will happen if you connect 10 bulbs like this? 10 bulbs like this. What will happen? And I'm going to connect it once again to our household electricity, 230 volts. What will happen? As there are 10 bulbs across the system which are connected in a series connection, this voltage is getting divided into 10 equal parts. But my dear children, specialty here is that in order to divide into 10 equal parts, these instruments should be equal in all aspects. They should be identical in all aspects. If one bulb is larger than the other, I mean like if it can bear like more voltage, then it's not getting divided equally. However, now in this case, I took all the bulbs are equal in all aspects. So in this case, 230 volts is getting divided into 10 equal parts and voltage across just one bulb is just 23, but it can bear 25. That means, my dear children, in this case, all the 10 bulbs will light up at a good brightness, and specialty here is that there is no harm in connecting these things to the main switches. I mean like in your normal houses, 230 volts, it's not going to be a problem at all. So one is going to be burned down for sure, but if you connect 10 of them, they are going to light up the system quite well. It's because that this is the case. With the increase of bulbs connected in series across a voltage supply, right, what will happen? When increasing the number of cells, we can get a more brightness by increasing the number of cells. However, several low voltages, like 10 here, several low voltage bulbs can be lighted up by using a very high voltage supply when they are connected in a series connection. So this is the one which is going to happen. If you connect one, then that is going to blast for sure. It's going to burn for sure. But however, if you connect 10 of these bulbs, then we can work with our household electricity. But remember, they should be connected in a series connection, not a parallel connection. So that's how those streams of lights are getting lighted up by using 230 volts of a normal household electricity. Even though they have very less amount of voltage, we can light them up by using very high amount of voltage supply if those things are connected in a series connection. Right then, now we are about to discuss the second activity related to the bulb systems. So it is given that, my dear children, parallel bulb systems. Parallel bulb systems, right? Here we are discussing about parallel bulb systems. Right, now let's see what are parallel bulb systems then. So first of all, we need to identify the materials that we need in conducting this activity. So let's write down the materials given here. First of all, to connect, we need wires. Then we need a switch to turn on and off the circuit. Then dry cells to provide electricity. Then torch bulbs. These are the appliances that we use to check what happens with the parallel connection. So bulbs are the ones which are which can be used to check the voltage or whatever the component, key components in here, because by checking the brightness we can come into a conclusion, right? Okay, so these are the materials that we need in conducting this activity. We need torch bulbs, dry cells, some switches and some wires. So you are given with three figures once again, right? You are given with three figures once again. Number one, the first figure. In the first figure, just one bulb is connected. In second figure, two bulbs are connected in a parallel connection, but there is only one dry cell. The third figure, three bulbs are connected parallel to each other, but by a single dry cell. Right. So my dear children, let's see what is our method in doing this activity. Connect one bulb with a switch and a cell as shown in the figure 1. According to the figure 1, one bulb, one switch, one cell. Connect two parallelly connected bulbs to a switch and a cell as shown in the figure 2. Two bulbs, just a one cell with a one switch. Remember, the two bulbs should be in a parallel connection. Then connect three parallelly connected bulbs to a switch and a cell as per to figure 3. So as per to figure 3, three bulbs, just a one cell with a switch. Right. Now switch on all three circuits at the same time. Observe the brightness of the bulbs. Right. Then we have to prepare these three circuits. Then after, you have to turn on each the switches and observe the brightness of the bulbs. What happens with the brightness? Right then. So my dear children, once again, let's head on to the lab and we'll conduct the activity and let's see what's going to happen with the brightness if the bulb system is parallel to each other. Okay, my dear children, now in the earlier activity we discussed about the series connection of bulbs. Now in this activity we'll be observing or we'll be investigating what happens, right? What will happen when you connect bulbs in a parallel connection. Okay, so first of all, I have prepared the three circuits according to the diagrams which given. Now the first circuit is this. This is the first circuit, not this one, but here you can observe the first circuit. One dry cell, one dry cell, a switch, and this is our bulb and the holder. So when I'm going to turn on this switch, you can see the bulb is going to light up. Okay. Then after that, the second system, once again you can observe the switch, just a one dry cell and two bulbs which are parallel connected to each other. How can you say that these two are parallel connected? It's simple. See, red terminal, red terminal. Usually you know that the red terminal is positive. Two positive terminals are interconnected by this wire. See, two negative terminals are also interconnected by this wire. See, and finally these two wires run towards the dry cell through this switch over here. So it's really a simple setup. However, identify the connection between these two bulbs. So that connection is a parallel connection, as the two negatives are interconnected each other with the two positives like this, and they run towards the system over here. Alright then, so this is the parallel connection of second system or the second circuit. Now let's turn on the switch and let's observe what will going to happen. Now here you can see, let's open the first one as well, keep in the same way. Now here you can see, even though in the earlier activity, when the two bulbs are series connected, just one bulb give out a very small bit of a brightness. However, in this case, both the bulbs are showing equal amount of a brightness. Both the bulbs are glowing, but still it's not giving out that much of a brightness. It's because we used only one cell over here. And if you check with the other one, here with this bulb, brightness of these bulbs are also similar. There is no that much change in it. So if you check the system, if you check the brightness is somewhat similar in this one and this one. Actually, there is a small bit of a change. It's because of the resistance of each of these instruments which are getting connected. So you know that there is a obstacle which is given by each of conductors when they are connecting with a certain circuit system, right? So there is some amount of resistance in each of these instruments. So you know that in the earlier lesson we discussed that when you are connecting several components like this, even the switches are also having some amount of a resistance. Each and every conductor has some amount of resistance. So when increasing the number of conductors in a circuit, some amount of resistance is provided. So upon that, there might be a very simple loss of energy, electrical energy. However, my dear children, right, if you compare the brightness, nearly it is getting equal in all these two instances. Now let's turn on the next one. Here we have two dry cells, right? We have two dry cells with three parallel connected bulbs. Now I am going to turn on this switch by using this one. See, all three bulbs are glowing very well. If you compare the brightness of these ones, brightness is very high. When you compare it with the other ones, brightness is very high. See, brightness is very high. So here we can say that when you are connecting these in a parallel connection, there is no division in the voltage like in the earlier case. The voltage is getting directly supplied to all of these bulbs at a similar rate. That's why they are showing equal amounts of brightness. Here also the same. They are showing equal amount of a brightness. right? And the other thing is that when you interconnect these in a parallel connection, right? When you interconnect these in a parallel connection, we can use these systems, right? We can use these systems in order to, like, we can operate these systems, like you can operate these systems for a longer time period, right? So that's the specialty in parallel connections. So if you take the parallel connections, usually in our household electricity, they also have parallel connections in our circuits. So this is the parallel connection of bulbs then. So during a parallel connection, always remember voltage is not getting divided, but the voltage is being provided to each of the instrument. Here it's bulbs, right? Each of the bulb in an equal amount. So the brightness of the bulbs would be the same. There is no difference at all. When you are increasing the voltage by providing 2 or more dry cells, we can observe the brightness of the bulbs are also getting increased. However, if you compare the brightness of bulbs, they have equal amounts. Okay, so this is the parallel connection of bulb systems. Okay, so in a parallel system, remember my dear children, each and every component has the same amount of voltage across it. So let's head on to the classroom and we'll write down our observations and conclusions from this activity. Okay, my dear children, so we conducted the activity and you could observe that there is no difference in the brightness of the bulbs, even though there are several bulbs in the system. Reason for this thing is when the bulbs are connected in a parallel connection. When the bulbs are connected in a parallel connection, my dear children, like in the previous case where it is being connected in a series connection, like that, the potential difference is not getting divided. The same potential difference is applied to all the bulbs. Same potential difference is applied to all the bulbs. Means that dry cell, we'll assume that we use now single dry cell. Now at that time we assume that, or let's assume that 1.5 volt is the potential difference. Actually, like most of the times you can't light up a bulb by using just a one single dry cell. It's not probable. I mean, like you can light up, but however the brightness is very low because of less amount of current. In order to light up, at least you need to have 2 dry cells, right? You need to have 2 dry cells at least. So by using 2 dry cells, you can get somewhat more accurate observations. So however, I was explaining about that parallel connection thing. So in a parallel connection, my dear children, the specialty is the total potential difference is not getting divided into several segments like in the series connection. The same potential difference is applied to all the bulbs at the same time, right? At the same time, all the bulbs is going to have the same potential difference. So that's what happens in a parallel connection. That's why all the bulbs in the system has the same brightness, right? So we can write down our observation like this. All bulbs had the same brightness. All bulbs had the same brightness. Reason for this thing is, under the conclusion we can write the reason. The same voltage is supplied same voltage is given to all bulbs. Same voltage is given to all bulbs, right? So same voltage is given to all bulbs in each circuit, even though there are different number of bulbs. So in a parallel connection, my dear children, specialty is that like in the series connection, right, the voltage is not getting divided, right? The same voltage is being provided for all the bulbs at the same time. That's why they are going to have the same brightness. So same voltage is given to all bulbs in each circuit, even though there are different number of bulbs. So that's why they are going to illuminate in the same brightness. Right then. So we discussed about the connection of bulbs, systems of bulbs. So, and we first figure out how to connect different cells, different number of cells in a circuit. So, for the connection of bulbs, or else for the system of bulbs, and for the system of cells, for the connection of cells, we learned that there are two types of connections: series connection and parallel connection, my dear children. So now we are about to discuss the second main chapter of the lesson, second main topic of the lesson. So here we are discussing specially about simple electric circuits. So under the simple electric circuit, you are given with the first one, electric torch. The electric torch. So when I was starting the lesson, I gave you a simple explanation about the torch. Gave you the simple explanation related to the torch, right? So the electrical torch that we use in our day-to-day life, right, is being more often used in dark times, or when you're traveling in dark to get or to see objects. So let's find out what is the internal structure and the circuit of a torch then. So here it is given, electric torch is an essential equipment when we are going in dark at night and when we are in search of something in dark. So first of all, you are given, why do we use an electric torch in these kind of instances? To search something in dark, to travel in dark. So in that cases, we use the electric torch. There are electric torches with only one dry cell or with several dry cells connected in series. So, my dear children, the specialty in electric torch is that the cells, the dry cells that we use are connected in a series connection. These are connected in a series connection, right? So series connection is going to provide a good current to the electric torch. That's why it is going to bright illuminate, or that's why the torch bulb is going to give out a good brightness, because more current is getting provided by the batteries to the torch. So the bulb would give out a more brightness. Okay. So series connection is the reason to have a good brightness in the bulb. So next it is given, the figure shows an electric torch. So in the figure you can observe that electric torch. So this is the electric torch, my dear children. So first of all, you can observe the bulb, the torch bulb. It's been connected to a holder, right? It's a holder. You can, like rotate this bulb here and there it has a holder. So holder is the one which is observed in here. So the surface, this surface is curved and it is having a concave shape, right? It's having a concave shape like this. So the light would come and hit this concave surface and would travel parallelly like this, okay? And this surface is highly reflective. This concave surface is highly reflective. So the reflector, it has a high ability, like a mirror. It has high ability of reflecting light, okay? So this is the reflector, that concave reflector. Then after that, the holder is connected with connectors. See, these connectors can be wires. Most of the times we don't use wires, okay? We use metallic plates, brass or copper. Most of the times we use copper, right? Copper plates. So these are conducting connectors, simply copper plates, and there is a switch. Now in the switch also, a copper plate is moving here and there like this, okay? Copper plate is also moving here and there like this, see? So when you move the switch to there, this copper plate is going to touch this terminal, right? So by that way, the circuit is getting completed. Here the tip is connected with the positive terminal. Then the metallic cover is going to come like this. Metallic cover is connected like this and it is coming to here, the one terminal. This positive is connected to positive. So the negative terminal coming through the spring here and for the connectors, and it is connected with this terminal of the switch. So when you take this switch to the front, this metallic plate or this copper plate is going to touch with the second one in order to complete the circuit. So by that way, the bulb is going to light up as the connection of the circuit is getting completed when you turn the switch to that side, right? So here this circuit is getting completed. So this is how an electric torch is going to work. So there are dry cells to provide the electricity, which is connected in a series connection, and there is a metal spring and we can like rotate this spring, right? So there are like a small bit of a cup like thing, we can insert this thing and we can rotate it. So it's necessary to have this spring. It's because that it would firmly fix the dry cells within the system, right? Otherwise the dry cells would move here and there if it is not firmly fixed. So spring is providing a good firm grip for the dry cells, right? So when you are turning this cup to your right hand side, then that cup is going to be tightened on the torch and the spring is getting pushed towards the dry cells and the dry cells are getting fixed very well to the system. So this is how a torch is being prepared, okay? And this is how the current is going to flow through the circuit of a torch. All of these things are metal conductors. Within the structure, all of these things are metal conductors, right? The spring is also a metal conductor. That spring is connected with the connecting conductors, those metal plates as well. So this is the diagram of an electric torch, my dear children, a simple electric torch. And this is how the torch is going to work, right? So once again, you are given with a good explanation here. Let's see. As shown in the figure, dry cells, bulb, metal spring and conducting connectors of this torch are connected with each other. But the circuit is opened because of the switch. Now the switch haven't been pushed towards that direction. So therefore the circuit is open. See here you can observe there is an opening. Therefore the bulb does not light. When the switch is pushed forward, the gap between the conducting connectors, so here also there is a small bit of a mistake. It should be connectors, right? Oh, so gap between the conducting connectors is closed and the bulb lights. So in here also conducting connectors, so when you push it like this in a conducting connector, right, the gap is getting closed down and the circuit is getting completed. So by that way what happens here is the circuit is getting completed and the bulb is going to light up. So this is how the simple electric torch is going to work. Right then. So my dear children, you are given with a simple assignment, right? Here you are given with a simple assignment. Here, using the circuit symbols for bulb, electric cell, switch and connecting wires, draw the circuit diagram for electric torch in figure. Now the figure is given here. Okay, so we have to draw the circuit diagram related to this figure. Okay, then explain the advantages of using a reflector in an electric torch. Right. What is the advantage of using that reflector? And the second one is that you have to draw the circuit diagram related to the torch given in here. Right, my dear children, then let's draw the circuit diagram related to the torch given in here. Right. So when you are drawing this diagram, my dear children, always use your ruler and use straight lines in representing these things. Okay. So always use straight lines. Draw it by your own hand. Just use the instruments and draw the relevant figure. So let's go ahead and draw it. So first of all, like this, then the dry cell. Let's do two different dry cells as there are two. Always remember to interconnect these. Right. Then the switch. Right. Now the bulb. Okay. And finally the switch. Right then. So this is the circuit diagram for the torch which given here. Okay. Okay, I'm going to take the slide somewhat up so that you can get a clear look. So this is the bulb, the torch bulb. So these straight lines shows the connecting wires or the conductors. Then the two dry cells given in here, plus the on-off switch. Okay, my dear children. So this is the circuit diagram related to the electric torch given in the figure. Now let's move on with the second question. Explain the advantages of using a reflector in a torch. So in this figure also you can observe, when you take this one, it has a concave shape. Speciality in concave shapes is that when you take a concave shape in grade 7, you know that this is called as the concave mirror. In grade 7, you have studied about the concave mirror. When specialty in concave mirror is that, my dear children, there is a thing called focus in here. Light rays which are fall into here, it's going to travel through the focus like this. This is how a concave surface is going to work in the process of reflection, right? So speciality in concave surfaces is that if you place a certain thing like in the middle of the object, I mean, if you place a bulb at the middle like this, what happens here is that the light energy is getting emitted like this, and that light energy is going to hit on the surface and travel parallel to each other. Always the light energy which is getting produced by a certain light source is getting produced like this. These light rays are spreading here and there. So these light rays which are getting spreaded here and there, that's why when you light up your room, the entire room is going to light up. Because the light energy given out by a light source is going to spread like this. It's not going to travel in a certain direction like this. I mean, it's spreading to here and there like this. It's not getting to a certain direction like this. This is a parallel beam of light. This is a diverging beam of light. Specialty is that in a diverging beam light, as the light rays are getting spread here and there, I mean when they are getting diverged, it's difficult to observe distant objects. When you place torch like this and when you switch on like this, if the lights are getting spread here and there, then you can't observe the objects at least in front of you, right? It's difficult to observe. But what happens if the light rays which are getting spreaded, what happens if you can like direct those light rays to a one certain direction like this, a parallel connection? By that way, the light would travel to a longer distance, covering a longer, like actually it's not going that much long, but however, the light is going to travel to a certain distance rather than in the previous case, right? And we can focus that light onto a certain object like this. In the earlier case, we can't focus that light directly onto a certain surface because the light is getting spreaded here and there. Okay. So concave surfaces has an ability to convert those diverged light beams like this into a parallel light beam. By that way, a longer distance is getting covered by that light. So that would make easy to travel in dark by using the electric torch. So it's an important case. Okay. And my dear children, I told you another benefit of using reflector in the earlier case. It's because we can reflect the light, right? It's been used to reflect the light to the front or to the forward, right? It's been used to reflect light forward. The second main importance is that the diverging light rays or the diverged light rays, spreading light rays, right, is converted to parallel light rays or parallel light beams by using the reflector. Okay, so those are the two main important advantages of using the reflector, my dear children. Right. So we'll write down the answers then. So this is the circuit diagram and we'll write down our answer. So second one, this is the first one, the circuit diagram of the torch. The second one, advantages of reflector. Advantages of reflector. Number one, helps to reflect light forward. It helps to reflect light forward to the front. That's why we need to direct the torch like this, forward. Okay. Then the second one is the important one. As light rays are spreaded or spreads, as light rays are spreads, or we can say as light rays are spreading. That would be better. So as light rays are spreading, it's important to make light rays parallel. As light rays are spreading, it's important to make light rays parallel. Reflector, I'll mention concave reflector. Concave reflector makes light rays parallel. Special ability of concave reflectors, they make the light rays parallel. So that's why, my dear children, if you take a light bulb, in a light bulb, it's like this. For inward it is concave, but however to outward it is convex. So by this way, light is getting spreaded very well all around the area. That's the specialty in light bulbs. Light bulbs are used to light up a certain environment, no? If you take a room, whole room should be lighted up, not just a beam which is coming towards down. That light which is given out by the bulb should spread all around the room. In order to spread even more, we can use this surface. For inward it is concave, however for the outward it is convex, right? So convex surfaces are spreading light rays. But if you take concave reflectors, especially concave reflectors. They are going to do what? They are going to send a parallel light beam like in the torch. Okay. So this is our answer. Right? This is our answer. Right? So first of all, the diagram, circuit diagram of the torch. Then after that, the two advantages of using the reflector, it helps to reflect light forward. And next one, as light rays are spreading, it's important to make light rays parallel. Concave reflector makes the light rays parallel, right? Concave reflector is going to help, or it makes light rays parallel, right? So these are the important advantages of using that reflector thing within a torch. Right, my dear children? So we started and we discussed the lesson part related with the simple circuits, and under that especially we discussed about the electric torch. So within our next chapter, we'll be discussing even more details related with the electricity lesson. So I'll meet you with the further things with our next chapter.